Hello students, this is Shachi. Welcome to my channel Crack Chemistry. Students, today I am going to explain a topic which is extremely important for the students of classes 9 to 12. The name of the topic is Relative Atomic Mass Part 1. In this session, I have explained the concept of relative atomic mass in a very simple and interesting way so that you will have a strong foundation in this concept, as this concept is extremely important for understanding other concepts of the chemistry also. Students, before starting, I want to remind you to subscribe my channel for getting information about further important uploads, and press the like button if you like this video and share this video with your friends also. So now come with me and let's crack chemistry. So our topic is measurement of masses of atoms and molecules. So first of all, we will see what is the concept of relative atomic mass. Students, you know that atoms are extremely small and their masses are also very small. The masses of atoms are so small that they cannot be measured even with the help of most sensitive balance. For example, the mass of hydrogen atom was found to be 1.6736 into 10 to the power minus 24 gram by an indirect method. If you look at this number, you can imagine that this number is such a small number that it becomes very inconvenient for us to use this number during calculations. For example, if you do calculations by using this atomic mass, you will find a lot of difficulty. Another thing is that it will be very difficult for you to memorize these small atomic masses. So this problem was overcome by introducing the concept of relative atomic mass. In this concept, an atom was taken as a standard atom and this atom was given a fixed mass, and the masses of other atoms were given with reference to this standard atomic mass. Let me explain this concept by taking a very simple and interesting example. Suppose there is a fruit seller. He came out to sell his fruits, but by mistake he left all the standard weights at his home. So how he can sell his fruits? The fruit seller is very smart. He will overcome this problem by taking out one of the watermelon from his bag. And this watermelon he has given a mass of 12 FMU or 12 WMU. So you might be thinking that what is FMU? It seems to be a very difficult thing. Children, FMU is fruit mass unit. So smartly he has given a mass of 12 FMU which represents fruit mass unit, or WMU which represents watermelon mass unit, to that watermelon. Now what he has done, he has divided that watermelon into 12 equal pieces. So what will be the mass of one watermelon piece? As the mass of watermelon was 12 FMU, so the mass of one piece, which is obtained by dividing a watermelon into 12 equal pieces, will be 12 into 1 by 12. That will be 1 FMU. So now smartly he has overcome that problem. He will use a piece of watermelon as a standard weight, and he will sell other fruits by taking this watermelon piece as a standard piece. So you can see here, suppose 2 apples are equal to 1 piece of watermelon. So the mass of each apple will be half FMU. I hope it is clear to you. Now I am extending the same concept to atoms. Children, as you know that atoms are extremely small, and just now we have seen that mass of one hydrogen atom was found to be 1.6736 into 10 to the power minus 24 gram, which is an extremely small number. And definitely it is very inconvenient to use this number. It is very inconvenient to memorize this small number. So how scientists have overcome this problem? They introduced the concept of relative atomic mass. In this concept, they have chosen one atom as a standard atom, and the masses of other atoms were given by comparing their masses with that standard atom. So initially, hydrogen atom was chosen as a standard atom. Scientists have chosen hydrogen atom as a standard atom because it was lightest of all other atoms. Therefore, they have chosen hydrogen. After some time, this hydrogen was replaced by oxygen. They have chosen oxygen because oxygen is more reactive than hydrogen and it forms compound with most of the elements. And finally, in the year 1961, International Union of Pure and Applied Chemists, they have chosen another standard element that was the most stable isotope of carbon. And this most stable isotope of carbon was given a mass of 12. So, the carbon 12 was chosen as a standard element. So, now you just try to correlate this with the concept of watermelon wala example. In this scale, masses of all atoms can be expressed with reference to this standard carbon 12 isotope. So, we can say that atomic mass of an element is a number which expresses how many times an atom of an element is heavier than 1/12th of the mass of the carbon atom. So as I told you that atomic mass of an atom can be expressed as the quantity which expresses how many times an atom of an element is heavier than 1/12th of the mass of a carbon atom. Children, just now I discussed with you that the carbon atom was taken as a standard atom and the mass of this carbon atom was given as 12. And this scale of expressing atomic mass was called as AMU. AMU represents the atomic mass unit scale. But nowadays, AMU has been replaced by U. What does U represent? U represents unified mass. So, I was discussing about the atomic mass of atoms. So, atomic mass of atoms in this scale was represented as a quantity which expresses how many times an atom of an element is heavier than 1/12th of the mass of a carbon atom. As carbon atom was assigned a mass of 12 AMU or 12 U. So 1/12th of this will be equal to 1/12 into 12, that will be equal to 1 AMU. So now we can define 1 AMU also. What is 1 AMU? 1 AMU is the quantity which is equal to mass of 1/12th of the carbon atom. Children, I hope this concept is clear to you. So as I discussed with you, atomic mass of an element is defined as the average relative mass. And what is the standard atom? Standard atom, we have taken carbon 12. Carbon 12 is the most stable isotope of carbon. So how we can determine the atomic mass of an atom of an element? Atomic mass expresses how many times an atom of that element is heavier than 1/12th of the mass of carbon 12 atom. So atomic mass can be determined as the ratio of mass of that atom divided by 1/12th of the mass of an atom of carbon. And just now I discussed with you the quantity which is equal to 1/12th of the mass of carbon atom is called as 1 AMU. I hope it is clear to you. And this scale is abbreviated as AMU. AMU stands for atomic mass unit scale, and nowadays AMU has been replaced by U. U represents the unified mass. So I already discussed with you what is 1 AMU. 1 AMU is the quantity of mass equal to 1/12th of the mass of an atom of carbon 12. Now, another interesting point I would like to mention here. The mass of 1 AMU has been calculated as 1.66056 into 10 to the power minus 24 gram. Mass of 1 AMU was equal to 1.66056 into 10 to the power minus 24 gram. And in the previous slides, we have seen that mass of an atom of hydrogen is equal to 1.6736 into 10 to the power minus 24 gram. So, what we can do? We can find out the mass in terms of AMU. So, in terms of AMU, what will be the mass of hydrogen atom? We will find out the ratio of masses of hydrogen to the mass of 1 AMU. 1 AMU is also called as mass, which is equal to 1/12 of the mass of carbon atom. So, if we find out the ratio of mass of one hydrogen atom to the mass of 1 AMU, the answer will come out to be equal to 1.008 AMU. So, children, remember that in terms of relative atomic mass, the mass of hydrogen atom is 1.008 AMU, but for our calculations, we use the quantity 1 AMU. To make our calculations easier, to make our calculations simpler, we use 1 in place of 1.008. I hope it is clear to you. Similarly, the mass of oxygen atom was found to be 15.995 U, which we have replaced as 16 U, and the mass of nitrogen was found as 14 U, and the mass of sulfur atom was found as 32 U. So what does it mean? It means that an atom of hydrogen is 1.008 times heavier than 1/12 of the mass of carbon atom. Or we can say that an atom of oxygen is 16 times heavier than 1/12 of the mass of a carbon atom, and so on. I hope this point is very, very clear to you. Children, thank you so much for watching this video. And don't forget to watch part 2 of this video, in which I am going to explain very, very important points. Thank you so much. Have a nice day.